SHL, together with its partners ArtiMinds Robotics and Schunk, successfully automated a highly challenging weld finishing robot application for a globally operating water technology company. The customer looked for a flexible solution without any pneumatic spindles, since those are hard to monitor and cumbersome to maintain. SHL decided to realize the automation solution with a force torque sensor and a pneumatic gripper from the robot accessory provider Schunk in order to meet the required process compliance. A KUKA robot and several high-speed spindles and grinding wheels completed the setup. The workpieces, which vary in size and dimensions, consist of several pipes welded together. The task was to remove the excess material at the weld seam on the inside of the workpieces. Programming such force-sensitive tasks typically requires a high level of robotics and programming expertise. However, with the software solutions and programming support from ArtiMinds, SHL set up, commissioned, and identified the optimal process parameters in just a few days. The CAD2 Path tool of ArtiMinds' robot programming suite is key for a successful realization. After a quick import of the CAD model of the workpiece, the user selects the weld seams that need to be removed. Various features help to minimize the need of manual inputs by the user, such as creating an offset of the path based on the used tool. By animating different TCP orientations on the path, the user can quickly find the right settings and move forward. Enabling force control will use the force torque measurements to ensure the right contact pressure between robot and workpiece. Based on the selected edge, ArtiMinds RPS generates a suitable path representation the robot shall follow. This representation is stored in a template. Finally, the user just needs to compile the program. ArtiMinds automatically generates native KUKA code containing the set force control parameters. With SHL's process expertise, an oscillating motion has been overlaid to ensure a perfect material removal process and optimal surface finish. During commissioning, ArtiMinds Learning and Analytics for Robots software helps monitoring the process performance and identifying optimization potentials. Process-specific graphs can be created by the user to get deep and detailed insights, which are not possible to retrieve just by visual inspection or noise checking. This graph allows to analyze the force-torque sensor data and the response time between an incoming force measurement and a robot movement adaptation. The user can clearly see the approach motion of the robot to the workpiece, the first contact point with the tool, and the overall oscillating material removal motion. The 3D view visualizes any occurring vibrations that point to necessary optimizations of the parameter settings of the force torque controller. Questions like, what is the magnitude of vibrations? What forces are caused by them? Where do the vibrations occur in the machining process? What influence do vibrations have on the result of machining? And many more can precisely be answered with ArtiMinds LAR. The different visualization options allow a comprehensive analysis. Thus, the force time diagram additionally provides information on the overall process performance. Both diagrams make the robot vibrations at the beginning of the process clearly visible, and it is obvious that the initial setup and parameter settings need to be optimized. But instead of blindly or randomly trying different parameter settings, LAR provides objective, measurable data that allows the appropriate parameters to be quickly changed and optimally adjusted. Adapting these program parameters in ArtiMinds RPS and then rechecking the process performance in LAR leads to an optimal setting without vibrations that negatively affect surface finishing. These are just a few examples of ArtiMinds LAR's benefits. Fitting to the user's requirements, the analysis can completely be configured individually. This leads to holistic monitoring capabilities that improve the rapid setup of robotic material removal applications and ensure an optimal processing result.